continue this chapter by solving linear systems. Instead of graphing, we're going to use substitution this time. Let me remind you what substitution is. Let's say we have y equals 3x plus 2, and then they tell us to solve for y when x equals 1. What you do is you would plug in 1 for your x value up here. Y equals 3 times 1 plus 2. You would substitute 1 into the x, and you would solve for y. That's substitution. We're going to be doing that, but on a bigger scale. Okay, so this is just an example. We're going to be doing problems that look like this. Y equals 3x plus 2, and the other equation is x plus 2y equals 11. Okay. Our whole goal is to use substitution to find an ordered pair. Our solution is an ordered pair. Over here, I'm going to list the steps in which it takes to find that ordered pair. I'm also going to put that up here. Solution, oops. We're looking for an ordered pair. So what you're going to do is you're going to make sure one of the equations has a variable by itself. So look at these two equations. The top one has a variable by itself. It has a y by itself. The bottom one doesn't have a variable by itself, but that's okay. One of the equations has to have a variable by itself. So what I'm going to do over here is I'm going to say step 1. One of the equations has to have a variable by itself. Again, in this example, our top equation has a variable by itself. Step 2 is to substitute that value into the other equation. Okay, so this variable is by itself. I'm going to substitute this value into the other equation for that variable. So this y is going to be replaced with this information. X plus 2. Now, because this has more than one term, I'm going to use parentheses. They're multiplying, so I'm going to multiply here. Do you notice when I substitute this value in for y, the y's cancel out? I'm left with an x. Your next step is going to be to solve for, in this example, x, but solve for the other variable. So the opposite variable in number 1. Okay, so I'm going to solve for x here. My first step is going to be to do the distributive property. 2 times 3x is 6x. 2 times 2 is 4. I'm going to combine my like terms. This is a 1x, that's a 6x. (11 minus 4 is 7. So now I have x equals 1. Remember that our solution has to be an ordered pair, so we only have half the value. Your next step is to find the y value. To do that, you're going to plug the x value back into one of the original equations. It doesn't matter which one you choose. I'm going to choose this equation right here because y is already by itself. You're still going to get the same answer as if you were to choose this equation. So y equals 3 times 1 plus 2. Find y. We have 3 plus 2, which is 5. So now I have an x value, I have a y value. I can write my answer, 1, 5. Okay, so we have to catch our steps up over here. We have to add a step 4. Let's see here. Solve for the other variable opposite in number 1, so that was the screen stuff. We got an x equals, so now you're going to plug. We're going to say plug number 3's answer into an original equation. And then form an ordered pair. Okay, hopefully those steps will help us with the next problem. Let's try another one together. Let's try y equals 2x minus 3 and x plus 3y equals 5. Our first step, one equation has to have a variable by itself. Again, this top equation has the y by itself, so I can move on. Number 2, substitute that value into the other equation. So this value y, well this value stands for y, and I'm going to substitute that into the other equation. I'm going to replace y with this information. These are multiplying, so I have to set up a set of parentheses. All I did was replace y with this value. Step 3, solve for the other variable opposite of number 1. So this variable is y, we plugged in information for y, now I'm going to solve for the opposite, which is x. This is the distributive property. 3 times 2x is 6x. 3 times a negative 3 is a negative 9. I need to combine my like terms. These are on the same side, so I'm going to do whatever it says. This says 1 plus 6. To get x by itself, I'm going to bring the non-variable term over first. Divide both sides by 7. So I get x equals 2. We only have half our answer. We need to have a y value as well. So number 4 says, plug number 3's answer. Number 3 was to solve for x. Plug this answer into an original equation. It doesn't matter which one, you can pick either or. I like to pick this one because the y is already by itself. I'm trying to find a y equals. So y equals 2 times my x value, which is 2, minus 3. So y equals 1. My ordered pair, xy, is 2, 1. Okay. How about you try one? Try to find the ordered pair to these two equations. Y equals 2x plus 5. And the other equation is 3x plus y equals 10. Push pause and try that now. Okay, this takes a lot of patience, so don't get frustrated. The only way to learn this is to try, make mistakes, learn from your mistakes, try again. Okay? Have lots of patience. You can do it. Step 1, one equation has to have a variable by itself. This equation has a variable by itself. Step 2, substitute that value into the other equation. This value needs to be substituted in for y. This time, this is not being multiplied by anything, so I don't need a set of parentheses. So that was my y equals 10. Step 3, solve for the other variable. Combine like terms. They're on the same side, so I'm going to do whatever it says. So I get x equals 1. Plug numbers 3 answer into an original equation. So we have to plug this into an original equation. Just to be different this time, I'm going to choose the other equation to prove to you it still works. Normally I'd pick this equation, but I'm going to use this one to find my y value. So my x value is 1. 3 times 1 is 3. Get y by itself, so I get y equals 7. Either way, you're going to get the same answer. Your final answer is an ordered pair. Okay, make sure you get that down. Okay, now try y equals negative 3x minus 7. The other equation is negative 2x plus 4y equals 0. Push pause and try that now. We are going to try a little bit harder problems now. Here are our two equations. Okay. Negative 5x minus 1 equals 12. And the other equation is 3x minus 5y equals 4. Step 1. One equation has to have a variable by itself. These two equations are in standard form. They do not have a variable by itself. So before you can substitute anything in, you need to create an equation that has a variable by itself. And there is a trick to this. You want to try to solve for a variable that doesn't have a coefficient. So I'm looking at this top equation, and I see that this doesn't have a coefficient here, so I'm going to solve for y in the top equation. You could solve for x or y in this equation, you could solve for x or y in this equation. Either way you're going to get the right answer, but one way is easier than some of the other. So I'm going to take this equation, this first equation, and I'm going to solve for y. So I'm going to bring the 5x over. I'm going to put the 5x first and the 12 second. Y is not by itself. There's a negative 1 in front of it, so I'm going to divide. I have to divide both terms by negative 1. Okay. Now look at our two equations. I'm going to rewrite them. The top equation is y equals negative 5x minus 12. And the bottom equation is 3x minus 5y equals 4. This looks familiar to the first page. Step 1, one equation has to have a variable by itself. My top equation has a variable by itself. Step 2, substitute that value into the other equation. So this y value is going to be substituted for the y in the second equation. They're multiplying, so this is the distributive property. The y value is negative 5x minus 12. This is the distributive property. I'm solving for x. Make sure you take this negative 5. Negative 5 times negative 5x is a 25x. Negative 5 times a negative 12 is 60. Combine like terms. Bring the non-variable over. I get negative 56. So I get x equals a negative 2. Okay. Our solution is an ordered pair, so we're not finished. We need to plug that answer into one of the original equations. I'm going to choose the easy one this time, this top one, because y is already solved by itself. The x value is -2. My answer is the x value and the y value put together in an ordered pair, -2, -2. Okay, this one looks a little different. Let's try this one together. X minus 2y equals a -6. 4x plus 6y equals 4. Step 1 equation has to have a variable by itself. Again, both of these are in standard form, so there are no variables by itself. We have to force it to have a variable by itself. That variable by itself so far, this whole video, has been y. We've gotten y by itself. That does not have to be the case. You can get x by itself as well. So my tip before is you can solve for any variable here to get it by itself, but to make it easier on yourself, you're going to want to solve for the variable that has no coefficient out front. So I'm going to solve for this x this time. So I'm going to take this first equation, I'm going to move it around so I have a variable by itself. I'm going to keep this x by itself, so I want to move this to the other side. So I get x equals, I'm going to put 2y first, -6. Now there's a variable by itself. I'm going to rewrite this so we can see it. Our first equation, x equals 2y minus 6. Our second equation we did not change. Okay, so the top equation we have a variable by itself, we can move on. Substitute that value into the other equation. So this time, this x value is going to be substituted in here. 4 times the quantity, 2y minus 6. Now the rest of the equation. Notice by substituting the x value into the x, we get rid of x's, and this time we have y's. We're going to solve for y. Distributive property. 4 times 2y is 8y. 4 times a -6 is a -24. Combine your like terms. Do whatever it says. This says 8y plus 6y, which is 14y. Write down everything else. So I get y equals 2. I only have one of my answers. I need an x value. I'm going to substitute this back into one of the original equations. I'm going to substitute it into this first equation because x is already solved by itself. So 2 times y, or 2 times 2. And then my ordered pair is always the x first and the y second. Alright, I want you to try one of these. 3x minus 5y equals 13. And x plus 4y